Welcome students. So today we are starting off with coordinate geometry for class 9 CBSE. Okay. See, so far you had seen how to locate a point in a number line, right? So given a number line, you know how to locate a point in a number line. Let us imagine that in your city you have main roads and there are streets parallel to the main roads. Okay, so you have main roads, there are several main roads running, and you have many streets parallel to each of these main roads, both horizontally and vertically. So this is how a well planned city would be. See, if you had ever gone to places like Bengaluru or Chandigarh, for instance, the layouts are very well defined. So you will have mains and you will have cross, right? So the main roads signifies the major roads and the crosses signifies the streets, right? So if you have to locate, right, your friend's house in one of the streets, right? It is not just enough if you know that, where your friend's house is in terms of street, right? If someone says, okay, your friend's house is in the second street, right? Near to the third main road, second street, right? That alone is not enough, So you need one more information, that is the number, the house number, right, of the house where he is living. Okay, then only we will be able to pinpointedly say that his house lies here. Similarly, you take a sheet of paper, you arbitrarily put a point. Now you have to communicate to somebody, right, where your point is, exactly where your point is. Now, you cannot say it is in the upper part of the paper sheet, So if you say upper part, your friend can put a point or mark a point anywhere in the upper half, right? So it need not have to be exactly the same location where you have marked it. And if your aim is to guide your friend to exactly mark the point similar to where you have marked, right, then it is not just enough to say it is there in the upper half. It is not enough to say that it is in the bottom half of the sheet. It is not enough to say that it is on the left hand side of the sheet. It is not enough to say it is on the right hand side of the sheet, or it is not enough to say it is somewhere in the middle, right? So you would require, right, certain techniques, certain I would say strategies, right, to help or guide your friend to exactly mark the point where you have marked it, right? So you have to have some reference, isn't it? So for example, it could be, I have marked a point 10 centimeter from top margin and 5 centimeter from my left margin. See, this would help you to exactly pinpoint the point where you have marked, right? So, you see, you need at least two dimensions, two information, right? The distance where you have marked the point from the top of the sheet and the distance from either left hand side of the sheet or on the right hand side of the sheet. Then only your friend will be able to mark the point exactly where you have marked it. Okay, so whenever we talk about surfaces, whenever we talk about a plane, right, we need at least two information to locate a point in a plane. Okay, so this is what the great philosopher and mathematician Mr. Descartes, right? He is a French mathematician and philosopher. See, those days people who were spiritually very well advanced, who were philosophers, who were talking about how you must lead your life, the goods of life, etc. They also used to be very good mathematicians, because the researchers in mathematics is very similar to how you work towards knowing the ultimate truth in life, right? So spirituality and mathematics are very similar in their approaches. So that is the reason you will find in the history, if you go into the history, many great mathematicians who had put together great theorems or great theories of mathematics, they all were philosophers. Pythagoras was a philosopher, right? Thales was a philosopher. Euclid was a philosopher. So you find many people who were philosophers, who were spiritually very well advanced, and who also contributed immensely to mathematics, right? So Descartes was actually lying on the cot, and he was thinking to himself. I'm talking about several thousand years back, and he was thinking to himself, how do I, right? How do I locate a point in a plane, right? Because those days the thinking was that Earth is not round, it is flat. Okay, the Earth is flat. So how do I exactly pinpoint a point on the plane? Okay, so when I say a plane, right, again, the visualization of a plane has to be very correct. Okay, it is very important to visualize it in the right manner. All right. So when we talk about a plane, we are talking about, let's say we have Earth here. It's you imagine there is Earth, and the plane is something that sits on top of it. Okay. So that is the reason a plane will have breadth and length, right? It will not have height. All right. So this is what we call it as plane or a plane surface, right? Both signifies the same thing, right? So you should imagine whenever we talk about a plane, right, we are talking about a flat surface which is sitting on top of the Earth. Okay, so that is how you should imagine. So now Descartes wanted to locate a point in that plane because his thinking was, Earth is flat, right? That is when he figured it out that he would require two information to locate a point. So he thought of two perpendicular lines. See, the notion of number line was already there. Okay, the notion of number line was already there, right? So he said, let me take two number lines. All right, let me take two number lines, right? You have 0, then 1, 2, 3, 4, etc. the positive direction of the number line, -1, -2, -3, etc. negative direction of the number line. He took two number line, and then he placed each number line perpendicular to each other. Okay, so he kept one number line in the east-west direction. He kept another number line in the north-south direction. Okay, so you just imagine you have Earth, on top of it he is placing two number lines, one on the east-west direction and another one on the north-south direction. So the one that is kept in the east-west direction, right, he called it as x-axis. The one in the north-south direction, he called it as y-axis. So the point, right, at which the both x-axis and y-axis bisects each other or meet each other, intersect each other, is called origin. Okay, it is called origin, right? In other words, origin is a point where x-axis and y-axis bisect each other, intersect each other, and is generally denoted by the value 0, right? Right now we are only sticking on to the numbers as such, right? Now we will proceed, and we will try to see how to really identify or plot a point in this plane. Okay, so we will see that later, but let us first understand the building blocks of what Descartes had invented. So he first laid out these two lines, right? So he called them as x-axis and y-axis. All right, and the plane thus formed. See, you can visualize you have Earth on the north-south direction, right? You have y-axis on the east-west direction. You have x-axis, right? So that you are able to visualize, isn't it? So this particular plane that you are able to visualize, right? This particular plane that you are able to visualize, visualize it as a plane with the north-south direction as y-axis, east-west as x-axis. Visualize that. Okay, so this plane, right, is called as Cartesian plane, right? Because it is Descartes who invented it, hence it is called as Cartesian plane. Okay, it is also called as coordinate plane, right? The plane thus formed by these two number lines is called coordinate plane, Cartesian plane, or XY plane, because usually we refer this as x-axis and y-axis. Okay, hence it is called as XY plane. All right, so the I said the midpoint 0, that is the origin, right? Now you have different directions. See, on the x-axis from origin, when you move towards the positive numbers, it is called a positive direction of x-axis. Similarly, when you move towards the negative numbers, it is called the negative direction of x-axis. Now when you go towards positive numbers in the y-axis, we call it as positive direction of y-axis, and when we go down, we call it as negative direction of y-axis. Okay, so you have to clearly understand that there are two directions, positive and negative directions, for each of the axes, x and y-axis. All right. Now if you look at it, these axis is dividing the plane into four parts, right? Into four parts, isn't it? So if you draw like this, you have four parts. So the first part, where you have the positive direction of x-axis and the positive direction of y-axis, that first part is called quadrant 1, right? These four parts are generally called as quadrants. Okay, so the first quadrant is nothing but where the positive or the first quadrant is the area, right, enclosed by the positive direction of x-axis and positive direction of y-axis. Second quadrant is the area enclosed by the negative direction of x-axis and positive direction of y-axis. So it is the negative, second quadrant. The third quadrant is the area enclosed by the negative direction of the x-axis and negative direction of the y-axis. Okay, negative direction of the x-axis and negative direction of the y-axis, the area enclosed is called quadrant 3. Now the fourth quadrant is nothing but the area enclosed by the positive direction of x-axis and negative direction of y-axis. So for simplicity, the first quadrant, right, you find it is enclosed by two lines where the numbers both are positive, right? In the third quadrant, you will find it is enclosed by two lines where the numbers are negative. Okay. In the second quadrant, you will find the numbers on the x-axis are negative and numbers on the y-axis are positive, and in the fourth quadrant you will find the numbers in the y-axis are negative and x-axis are positive. So this is how you will remember about quadrants. Okay. Now if you take one point in a plane, let us say you have the first quadrant, you have 1 point, then how do you plot or locate that one point? See, you basically need to take the distance, right? Distance from the y-axis through the x-axis. When I say through the x-axis, you are basically traveling through the x-axis from y-axis. There is a distance, right? That distance, you have to identify what is that distance. When you measure it from y-axis to the point. Okay, so you have the y-axis, draw a perpendicular line to the point, straight line to the point, right? That matches with a particular distance in the x-axis. So that is the distance of the point from y-axis through x-axis. So it is called x-coordinate, right? The distance of the point from y-axis, right, through x-axis. Right. So when I say through x-axis, it is basically from a measurement perspective, because you have only x-axis to measure. It is like a scale. Okay. So when you are drawing from y-axis a perpendicular line to this point, just take a parallel into the x-axis. Measure what is the distance. That is the distance of the point from the y-axis parallel to x-axis or through x-axis. Okay. So this distance is called as x-coordinate. Now the distance of the point, same point from x-axis through y-axis. When I say that, parallel to y-axis. Okay. From x-axis, you draw a perpendicular to the point. Now measure what is the distance on the y-axis, right? Take the parallel distance. So you will get a measurement, right? So that measurement is the length of this perpendicular line, of the point, perpendicular line from the point to the x-axis. Okay. So this measurement, right, the perpendicular line from the point to the x-axis is called y-coordinate. So x-coordinate is nothing but the perpendicular line. When you draw a perpendicular line from the point to the y-axis, the distance, the length of that line is called y-coordinate. X-coordinate is nothing but you draw a perpendicular line from the point onto the x-axis. The length of that line is the y-coordinate. Generally, right now, since you will know that with reference to y-axis and x-axis, this point which is lying in quadrant 1 has now two values, right? We can say the distance of the point from the y-axis is 5 units, assuming it is 5, and the distance of the point from x-axis, right, is let's say 6 units. So you will be able to exactly locate the point. So you take 5 units on the y-axis, draw a perpendicular line, take 6 units from the x-axis, draw a perpendicular line where both the line meets. That point will be exactly 5 units distance from the y-axis and 6 units distance from the x-axis. Okay, so this number will be written as simple braces 5, 6. Okay, so this is only a convention. People might be asking, why can't we write it as 6, 5? Generally, right from the beginning, right from olden days, we are following a convention, we are following a standard that a number in a plane will be represented as open braces x coordinate, y coordinate, right? So x coordinate is nothing but the distance of the point, right, from the y-axis. Right, and the y coordinate is nothing but the distance of the point from the x-axis. Okay, so you will write x coordinate, y coordinate. In this case, it would be 5, 6. All right. So this particular, representation of a point as 5, 6 is called ordered pair. It is called ordered pair. All right, and x coordinate is also called as abscissa. Y coordinate is called as ordinate. X-axis x coordinate is called as abscissa and y coordinate is called as ordinate. Okay, so these are all the building blocks, right, of the coordinate geometry. Right, see, it is called as coordinate geometry because we are constructing certain things on the coordinate plane. As I told you, the Cartesian plane is also called as coordinate plane, right? It is also called as XY plane, right? So since we are doing all the construction on the coordinate plane, it is called as coordinate geometry. All right. So we have seen all the building blocks of coordinate geometry. In case if you have any doubts, please feel free to email to askmentorguru@gmail.com. Please feel free to ask any questions. See, I am also planning to bring in a few important questions that I have come across with regard to coordinate geometry in various competitive examinations. So that also I will be covering in my next set of videos, so that you get guidance as to how to approach certain type of problems. All right. So we will again meet in our next video. We will continue with the coordinate geometry. It is a very, very simple chapter, not very complex, and but this is the foundation. You have been initiated into coordinate geometry. Now as you move along in your next classes, advanced classes, you will learn about more complicated theorems and formulas, right? But in the 9th standard, what you are studying is only a foundation or an introduction to coordinate geometry. All right. Okay, so we'll meet again in our next set of videos. Until then, bye bye. You take care. If you have any doubts, feel free to email us. Please subscribe. Please press the bell button. Please share it with your friends. Okay, thank you very much.